our discussion about X bar and R control chart. Last meeting, we have discussed the formula or equation we use to calculate the control limits. So for each control chart, we have a pair of equations. This one. In X bar and R chart. Yeah, this one. And there's an assumption saying that we assume that the quality characteristic is normally distributed. So in the other words, the data point we collected from production line or from either from production line or from the feedback of the customer, as long as the data we use for setting the control chart. So the data we use, we assume that these data are normally distributed. Okay, so remember this is one of the assumption when we want to construct control chart. Okay, come back to the formula or equation we have discussed. So equation 6.2, I taught to you today. This is mean of the mean, or we say average of the process. You can set in the right hand side we have x bar 1, x bar 2 until x bar m, and then over. So you count how many. So they are m x bar. So divided by n. So we get x bar bar. So this is the center line on the X bar chart. And then we have discussed how to calculate the range. For the data we consider, we take the maximum minus the minimum. Okay, X maximum minus X minimum. I think there is one issue we have to alert it regarding to n's value. Okay, there are two subscript value we should understand. One is n nasi n's value. Another one is m Malaysia m. So you have to highlight here. Suppose that m samples are available, each containing n observation. So you have to really understand m equal to what, n equal to what, which number. So m equal to which number, n equal to which number. Then you can calculate x bar. So please do not misunderstand about n and m. Yeah, sometimes we confuse because when we say sample, how many sample? So when we're talking about how many sample, so it should be m equal to, right? You say I have 20 sample, so m equal to 20. And then when we're talking about subgroup, okay, subgroup. So observation, either we say subgroup, or we say observation, or we say measurement. So how many times or how many subgroup you want to observe for the same sample? Let's say I take one sample 20, then I make 5 observation. So each observation there are 20 sample point in the sample. So m equal to 20. So here in the slide, it mentioned that this sample point at least 20. Okay, at least 20. It can be more than 20. And maximum we will consider 25. Okay, this is in the input we use. Of course, it may be you ask, can I take more than 25? Suppose not a problem. We can take more than 25. But for our syllabus, we mentioned that 20 to 25 samples actually is enough. If you want to take more, suppose not a problem. And then declaring to observation, n will be small. So this n refer to the observation 4, 5, 6. Okay, this is just for suggestion. 20 to 25, 4 to 6. So once we understand m and n, then we can calculate x bar bar, we can calculate r range r. So these are the four equation we use. You see, one then we can do the calculation to get the average range. Okay, the average range. So the average range, the equation is actually the same as 6.2. Look, the structure is the same. And then we have 6.4. This is what this is what I have told you just now. A pair. So x bar chart, we have a pair. I mentioned a pair means that x bar bar plus a2 r bar, x bar bar minus a2 r bar. And a pair means that UCL, LCL. So there are two equations. And notice that I have mentioned to you before, actually the 6.4, we only need to remember one enough. Or equation 6.4 into 1, which is x bar bar plus minus a2 r bar. Then we know for plus term, for plus sign, it is referred to UCL. For minus sign, it is referred to LCL. And then without a2 r bar, then it is center line. So we just remember one equation, plus minus n is enough. And it, because this equation, when we say a plus minus b times c, so actually there are two equations, right? So the term after plus minus actually refer to tolerance. Yeah, in mathematical point of view, let's say 2 plus minus 0.5. So this plus minus 0.5 would be tolerance. So we apply that similar concept in this control limit. Yeah, so I think not familiar for you. You can easy to remember. But what is A2's value? I have mentioned to you A2's value, we can refer from appendix 6. Okay, appendix 6. We just refer to the n's value. Okay, n equal to what? How many observations? And then we can choose A2's value. Make sure you choose the proper A2 value. Yeah, after that, we have 6.5 control limit for the R chart. So compared to X bar chart, so this R chart actually quite simple because the center line is R bar, and then UCL, LCL, just D4 R bar for UCL, D3 R bar for LCL. So if we have a comparison, then you can see what I'm talking about. You just now simple is we don't have plus minus term for R bar chart's control limit. No plus minus term. Just simply D3, D4, and then multiply with the center line. It's quite simple. But one issue is what is D3 and D4? So again, D3 and D4 can be searched or can be referred from table 6. If we don't know D3 and D4, this D3 and D4 actually can be calculated. So regarding to the equation to calculate D3, big D3 and big D4, we have a discussion here, especially the derivation, how to get A2. So from here, so you can notice here, actually, this X bar control chart, R bar control chart, they are derived from 3 sigma, okay, 3 sigma control level. So 6.3, sorry, 6.7, you see, this 3 over the 2. So this 3, the number 3 actually is referred to 3 sigma level. So from here, we can summarize that A2 is equal to 3 over D2 square root of n. So last week I have mentioned or have shown to you how to get Okay, how to get A2 equal to 3 over D2 square root of n. So either we refer A2 from the table or we use 6.8 to calculate A2. So sometimes it depends. But for your information, big A2 and small D2, they are given in the table. But just in case in the question D2 is given, okay, just in case if D2 is given, table 6 is not given, then you know how to calculate A2. And then the same thing for the range. So actually we start from the center line R bar. So actually this R chart is some explanation here. So assuming that the quality characteristic is normally distributed. So again, you can see this assumption not only for X bar but for R chart too. So sigma hat R can be found from the distribution of the relative range. So we have range R. Then we assume that we have a distribution of the distribution of the relative range given by W, and this W is given by capital R divided by sigma. So the meaning of sigma is still the same. It represents the population standard deviation. We won't change the meaning. So the standard deviation of W. So sometimes we feel confused because when we read through the e-book or we read through the text, you can see that set D3. So this is to define that or to set or assume that or suppose that D3, okay, it means that we define D3, small d3 as standard deviation for the distribution of the relative range W equal to R over sigma. And then since we consider capital R, we have distribution of the relative range W equal to R over sigma. Then what is R? Then R is equal to W sigma. Then how to get the standard deviation of R? So sigma R equal to D3 sigma. Again, this is for standard deviation of R. So it just simply multiply. So standard deviation of R is equal to standard deviation of W multiplied the sigma. Since sigma is unknown, we may estimate sigma R by sigma hat. So again, this is what we learn in sampling. Okay, in the sampling, we want to estimate the point estimate. We also can calculate the confidence interval. So these are what we learn in sampling. So we apply the concept, the knowledge from the sampling, applying here. So again, when sigma is unknown, we need to estimate. If sigma is known, then we just use it. So what I mean here is, if sigma is known, we just use it. No need to calculate 6.9 sigma hat. So 6.9 actually is for estimate. Okay, estimated standard deviation of R. So remember, we calculate or we use 6.9 when the real sigma is unknown. If real sigma is known, then no need to use 6.9. Just use sigma equal to what? Just apply it. Okay, now, so substitute. Okay, now substitute the value into the control limit. So until today, we should understand that this control limit, okay, UCL, LCL, this control limit actually is based on the equation mu plus minus L sigma. So this L represents the distance, which is given by sigma level. So again, from 6.10, you can see R bar plus 3 sigma hat R. What is sigma R? So just substitute 6.9. So we get R bar plus minus. Again, we can combine these three equations into one. R bar plus minus 3 D3 R bar over D2. Then what is D2? From here, D3 stands for standard deviation of W, relative range. Then how about D2? I think it's not mentioned in the slide. Didn't mention what is D2. But you notice that since sigma is unknown, we may estimate sigma R by, and then you see sigma head R equal to D3 R bar over D2. So how to do the point estimate of standard deviation? Then you might understand that this D3 actually is the coefficient. Okay, to make the point estimate bias. So in point estimate, we have two items, right? We have two types. The point estimate is biased, or the point estimate is unbiased. So this is to make sure that the point estimate is biased. So we have the R bar over D2. Yeah, you can have a search, or you can have a review, or you can make a revision for the point estimate topic. Again, if capital D3 and capital D4 are not given, but the small d2, small d3 are given, then we can use the formula to calculate big D4 and big D3. But again, small d2, d3, big D3, D4, these four parameters actually can be referred to table 6. It means that we pick from the table, or we can do the calculation for big D3 and D4. But of course, we cannot calculate D2 and small d2 and small d3. They are from the table. But big D3 and big D4 either from table or can be calculated. We have mentioned that in quality control quality control involves two phases, phase 1 and phase 2. So in the phase 1, we will consider the control chart. So this is the purpose we discuss control chart for variable data, control chart for attribute data. So all the control chart we constructed actually is for the first impression. It means that when first time we collect the data, so from the control chart, what information can we obtain from the control chart? Yeah, because of this, the control limit from equation 6.4 and 6.5 can be called as trial control limit, because this is the first time we collect the data and this is the first time we plot the control chart. So of course, we have mentioned that 20 to 25 subgroup of sign n between 3 and 5. So when the first time, if we notice that not out of control, maybe we no need to do any checking. But if we want to take more, let's say after 20 or 25 subgroup, I want to take more than, I want to take another 25. Yes, we can observe actually, not necessarily take 20 to 25, but it could be a few trial. The first trial we have 25, let's say 25, and then another time or another set period we take another 25, so it becomes 50. This is to observe, or this is to check. Yeah. Just now I have mentioned you M and N. So again, this is why I said confused. You see, just now we have mentioned that M is sample size, M is sample, N is subgroup. But now you see, typically 20 to 25 subgroup of size N. So suppose not confused, but some of us might feel confused when we read through this sentence. So 20 to 25 subgroup of size N. So this 20 to 25 subgroup of size n. So this 20 and 25 actually is referred to n. And then subgroup, how many subgroup actually is referred to 3 and 5. Sometimes because the sentence or because the word make us confused, sometimes we misunderstand the n and m's value. But not a problem actually. When we are given a table, we are given a few set of data, then we know n equal to what? N equal to what? Yeah, later we try see whether you can recognize or not. So this is a phase 1 application of XBAR and R-chart. Yeah, later we will discuss how to plot the control chart using what? Excel. So this slide simply like explanation. So determine from M initial sample, try typically 20 to 25 subgroup of size n between 3 and 5. Any out of control points should be examined for assignable causes. If assignable causes are found, discard point from calculation and revise the trial control limit. Continue examination until all points plot in control. Adopt resulting trial control limit for use. If no assignable cause is found, there are two options. One, eliminate point as if an assignable cause were found and revise limit. Second, retain point and consider limit appropriate for control. If there are many out of control points, they should be examined for pattern that may identify underlying process problems. So if you refer to if no assignable cause is found, there are two options. So refer to this option. I think the second option I have mentioned to you in the preview classes. If we have some of the point out of control, so maybe we can enlarge, okay? Maybe we can enlarge the control limit. So this is called to revise control limit. But of course, when we want to enlarge or we want to revise a control limit, we cannot just simply remove. For example, if my UCL 10.1, but there is a point 10.3. So it is not simply just enlarge UCL from 10.1 to 10.5 to cover the outlier 10.3. So I don't suggest you to just enlarge, because to revise the limit or just simply to enlarge the control limit is easy, but sometimes it might involve some issue. So it is better we have to consider certain things like, shall we remove 10.3? Okay, remove 10.3, recalculate. If there are 20 points, one of the point is 10.3, but my UCL is 10.1. So can we remove 10.3? No 10.3. If I remove 10.3, so 20 point become 19. So for this 19 point, does my UCL still 10.1? UCL 10.1 is for 20 point, including 10.3, the outlier point. If I remove 10.3, is it my UCL still 10.1? This is need to consider. Or another one is, I'm talking about the first option. Then how about the second option? Retain point and consider limit appropriate for control. We don't want to remove 10.3. But from 10.3, okay, the outlier, we find out what is the reason why we have 10.3 this outlier in our sample. So we resolve, okay, we determine the assignable cause, we resolve, settle all the issue, and then recollect, okay, recollect, I mean another set of the point. This is after we have resolved the assignable cost. So the first is to just to remove outlier and then recalculate control limit. The another one, okay, another one is to resolve the assignable costs and then collect the set of the point or collect a few sample and then calculate again the control limit. So these two options, actually they are different. Just simply remove means that eliminate. So actually the example cost still there, we haven't resolved it yet. But for the second option, yes, we remove it. Yeah, so have an example. Maybe we have a rest for maybe 10 minutes. You try to, I don't know whether you have get your data ready. If not, maybe you can, I don't know whether you can key in the data or not. But it's okay. You try to, I give you maybe 10 minutes. You try to key in the data for this table 6.1. If in 10 minutes you cannot key in all of them, it's okay. Maybe you can key in until which? Maybe half. So how to key in? So you key in sample 1, 1, 2, 3, 4, 5. Sample 2, 1, 2, 3, 4, 5. So you key like this. It's better from you key in column by column. You understand what I mean? So you key in row by row. So first sample number and then by first 1, 2, 3, 4, 5. Okay, you try to key in row by row. So after 10 minutes, we will discuss how to calculate X bar and RI. Okay? Okay. How many of you? How many data you have keyed? Okay, so we wait another few minutes. Maybe some of you can key in the data in 10 minutes. Maybe some of you still blur. Yeah, it's normal. Because among us, we have fast learner, we have slow learner, and we have a medium. Okay, welcome back. Yeah, welcome back. So we continue. Okay, so this is the data. Okay, to get X bar. Before that, have a look at the data. We have sample number. We have sample 1, 2, 3, 4, 5. But sometimes we say sample 1, 2, 3, 4, 5. Maybe we confuse, right? So we said subgroup 1, subgroup 2, subgroup 3, subgroup 4, and subgroup 5. And then we said the size of the sample, each subgroup have 25 data. And then across the row, we will calculate the mean of 1, 2, 3, 4, 5. These 5 values. We want to get the mean. So use the formula. No, use average. Okay. And then you highlight these 5 numbers. You can just simply type. You can see on the screen. You can ignore the another number. You just focus on the command I type for you. You can see equal average and then in the bracket. So B5 dot F5. So B5 dot F5, either you just highlight the region or you can type B5 and then dot F5. But I suggest that after you type equal average, open the bracket and then you just move your cursor to highlight from B5 to F5. Okay, to make it simple. And then enter. No need to drag. Go to R. This R is to calculate the range. So what shall we do here is type equal and then maximum, and then highlight this 5 number along the row, and then this is to ask Excel to select the maximum number from 5 offer, from 1, 2, 3, 4, 5, pick a maximum number, and then minus, again use a command minimum, again highlight this 5 number, minus, or we ask software to choose the minimum from waffle 5 until waffle 1 to waffle 5. So this is maximum. Pick the maximum one minus the minimum one. This is to calculate the range. You get these two values. Yeah, I highlight these two values. Make sure you can calculate these two values. Then okay, you highlight these two values, and then you see the cursor from white color. When we move the cursor to this area, you see the cursor become black color. So double click. But what happened? Yeah, because it cover until the last two. So again, so we can try it until here. Yeah, remember we will fill in these two columns first because we want to calculate X bar and R bar. So these two values, we can do it one by one. Actually, we just need to do one enough. So you just simply type equal and then sum. And then you can highlight. You just simply highlight the column until here. and then close the bracket. Okay, so this is the command. This is the command to calculate the sum. Enter. And then this is to get the average. This is the row. Average. 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 Yeah, I think the command is wrong. Wait for a moment. Okay. Yeah. So once we get the sum, so the next thing is to get the average, which is x bar bar. So either you do like this, you just simply type equal and then point to 37.6403 and then divide by 25. Or you can just click like this. You click on 37.6403, divide, and then you click on 25, enter. Or you can use this command, average, and then you highlight from G5 to G29. Then you also will get the same value. So we no need to have so many floating number. So in the calculation, we will give until at least 3 decimal places. If you use calculator to calculate, yeah, the same thing, reserve for 3 decimal places. Okay, at least 3 decimal places. 2 is too less. Okay, 2 decimal places is too less. It's so less. So to make sure you give your value in at least 3 decimal places. So after you have done this one, so for R column, yeah, you just simply drag, then settle. Okay, now we want to calculate UCL. Okay, I want to remind you when we plot X bar chart, R control chart. Okay, when these two chart together, it is better to plot R control chart first. Okay, it is better to plot R control chart first to observe any variability as happen or not, to see any variability. Okay, variability. We want to know any variability happen or not from the R control chart. After that, we just plot X bar control chart. So now we calculate UCL for R chart. How to calculate UCL? Yeah, use the formula R bar times D4, right? So from the table, D4 is 2.114. And then LCL, yeah, if you do the calculation or you refer to the table, capital D3 actually is equal to 0 for n equal to 5. Capital D3 equal to 0. Okay, so you just simply type the command like this. Okay, I repeat. This is the command for UCL. Just simply type what is hash 31. This value, you see, hash 31. So we want to fix the value at hash 31 because we want to read this value. Okay, we will fix this value. I mean, we will take this value from hash 31 and we won't change the position. So we should put the dollar sign. If not, then when we drag the value to the next column or to the next cell, to next position, hash 31 will become hash 32. So we don't want, we want to fix the value. Okay, in the other word, this is a constant. We don't want to this constant change the value. So put the notation dollar. Okay, this is for UCL. And then for LCL. And then for ABA we read from this value. No, this is the sum. This is the ABA, 5.1467. So simply type #31. And then to make it simple, you can just simply type equal and then read from the first. So once we have done the first row, so the rest you can just write to the end. Again, no need to have so many decimal places. So at least 4. Okay, settle. So to plot the R control chart, so how many information we need? UCL, LCL, and then ABA, right? But if we have these two information, it's just an empty control chart. So we also need to plot. Okay, we also need to plot the data R into the control chart. So we just simply highlight these 4 columns. Okay, just simply highlight and then plot the graph. Okay, go to insert, choose. Okay, choose this one, 2D line. Okay, 2D line. If you don't want to have a point on the line, you can choose the first 3. If you want to see the point on the line, you can choose the last 3. So here I want to choose the first one. What happened? Okay, do it again. Only 3 line. Where is the... Okay. Highlight again. Okay. Highlight this 4 column. And then insert. Bigger look like this. Easy, okay. Double check. I think something is wrong. I look like so different. Okay, double check. Wrong. I cannot get the right one. Okay, we should get. Yeah, we should get this graph. Oh, it means that I get the wrong. About wonder. You see, something happened because just now I tried. Yeah, because I put here 20, I click on 25. So it should be a dollar sign here. Suppose I want to fix 25. When I write, you see, 25 is fixed at there with the dollar sign. If no dollar sign, then when I drag the value to the left-hand side, to the right-hand side, 25 will move to 1.5797. So be careful when we use the value, which value we want to fix it. So make sure you put in the dollar sign. Okay, now my UCL is right. My LCL is right. Again, highlight this 4 column. Oh, sorry, not including S bar. Okay, highlight this 4 column. R, UCL for R, LCL for R, and R bar. And then go to insert. Okay, now I want to choose the 5th one. No, the 4th one. So this is R control chart. So make sure you give the name. So either you put R chart or R control chart. So to make it simple, we can just put it R chart. Then label. So normally we no need to have region. You can label. Okay, you can label UCL equal to what? LCL equal to what? LCO equal to what? Center line equal to what? Okay, you can label. And then the most important thing is axis. What is x-axis? So you can see x-axis subgroup, y-axis sample mean. So we can just simply put here subgroup, and then y-axis sample mean. Similar to figure 6.2, you can have a comparison. Okay, this is our chart. This is our chart from ebook. We should get the same. Okay, so this is our chart. So make sure you can get this R chart. You only can see, or you only see 2 lines, right? At least maybe put it here. Okay. Can you get the R chart? Okay, now we go to the next for X bar chart. So I will keep this one, or maybe I just delete. So for X bar is the mean of the mean. So this is X bar mean. So you will read this value or this value the same, right? So I will take this value. So this value is at G31. So just take equal to G31. The next, you can just simply click refer to the first. And then for UCL, remember the formula? X bar plus A2 R bar. A2 equal to what? From the table, A2 is equal to 0.577. So you just simply type equal L5 plus 0.55 times K3. So if you follow my position, then you can follow my command. If not, then you have to refer your position. Where is your R bar? Where is your R bar? Where is your X bar? Where is your R bar's position? And then you click on it. And the same thing for LCL. Make sure you put them in order, and then you can just click on it, or you can just type the position. And then this X bar actually is from here. Okay, these two are the same. So I just put X bar together with, okay, I just put X bar together with X bar, LCL, UCL. Why? Because when I want to plot the control chart, I can just simply highlight like this. If I don't want to put together, I can simply like this. I can do like this, highlight X bar, and then control, and then I highlight another three, X bar, UCL, LCL. Also can, no problem. So we highlight the separated column. So I think it's easier if we can put them together, then we can simply highlight like this. It's much more easier. But of course, when we fill in the first column, okay, when we fill in the first column, when we want to fill in this table, after we fill in the table, we can just plot the control chart. So make sure X bar you read from the first value, and then this one we can just write, okay, and then highlight the second row, and then drag to the end to fill in the table. Once we complete the table, then we highlight these four columns, and then go to insert and then plot the control chart. Okay, so this is the control chart. I don't want region. I just want to insert. Okay, again, this is for sample mean. This is for subgroup. And for this, my control chart, my X bar chart. And then I can put here X bar chart. Okay, refer to the table, refer to the ebook. Yeah, we should get this control X bar control chart. But you see, my control chart, my X bar control chart, all are located, or all are what we call, all are distributed around 1.5 to something, right? Around 1.5. I mean, this figure is not a good figure. So what shall we do? We can zoom in, okay, by changing the value of x-axis. So you just point on x-axis, point on y-axis, and then click format axis. So we want to zoom in. So we can change minimum. Don't want to start from 1. We want to zoom in should be start from 1, isn't it? 1 is better, or 1.2 is better. See how it's better, right? Subgroup, there is a typo. Okay, so compare with the table, compare to the chart in the ebook, we should get the same. Yeah, you can double check. This control chart should be the same as what we have plotted. So this is X bar chart. So you get the idea how to plot the R chart and X bar chart. Actually, to plot the control chart, not simple, not difficult, very simple one. But there are so many calculations. So make sure you can calculate the value, especially for X bar, R bar, and then calculate the control limit. To calculate control limit, not a problem. The problem is if we are given many data, like this example, one subgroup 20, then we have 5 subgroup. If you use calculator or by manual, can you calculate each of them? Sometimes we are given 50 data. Yeah, you see, when the data are so many, to calculate X bar bar, to calculate R bar, it is time consuming. So that's why it is better we understand how to use software. So either we use Excel or we can use other software to make our calculation more simple. Then the rest, I mean, once the value, once once the value are ready, then we can just highlight them and plot the control chart, R control chart and X bar control chart. So it's very simple. So this is one thing. Another thing, this is after we can get the control chart. So the first thing is to get the control chart. The second thing is from the control chart, can we do something? Can we interpret something? Now, of course, this is in the phase one. Once we get the R control chart, X bar control chart, so we want to observe, does any point out of the control limit? So from this X bar control chart, you see this is R bar, X bar control chart. So all the point represent the sample mean, right? Process mean or average, process average. So the process average, all the process average are inside the control limit. So we can say that this process is in control. We do not notice any out of control signal happen. So at this point of view, then we no need to find out what is ensemble causes. So it means that this is a safe. Okay, this is safe our time. We no need to do troubleshooting because the sample we collected are inside the control limit. But in the real world of QC, you see this time we have 5 observations and then 20. Then of course, in one day, we not only do it one time. So let's say in this time, I have this 5 subgroup and each subgroup have 20 at this time. After 1 hour or 2 hours, I will collect another 5 subgroup, each subgroup 20. So within one day, I will repeat this work. I said checking work. Okay, I will say checking work or observation work. So I will repeat this thing few times in one day. Maybe I might repeat 4 times. In morning, I collect this 5 group 20 data in morning, maybe in early morning, and then in the noon, and then afternoon, and then evening. If my production or my company, the production line run 24 hours, maybe in one day, 24 hours. So in one day, I might have 6 hours, one checking. So it depends on the company, okay? And depend on what is the gap or what is the period we want to do the next sampling. Of course, you do it one, not enough. For quality checking, do it one enough, not enough. We need to do several times to ensure that the production produce the. You can imagine if you just check one time, let's say you check in evening, it's okay, but maybe some quality issue might happen in noon or in the morning, but we do not notice. You can see if the product with quality issue or with some defect, and then we do not detect it. You as a consumer, when you receive a product or you receive a goods with defection, so what do you think? Do you want to still using my product? Or you want to complain my product? It's good if you come to see me and then you tell me, yeah, boss or manager, your product, let's say I produce printer, you come to see me, or you complain to me, or you come to my customer service, you complain with them, yeah, my product, the printer, when change the printer head, cannot print, the quality of printing is low, you should improve. Yeah, it's good if you come to my company and tell to my customer service. But the worst thing is, as customer, you don't come to company, but you tell to your friend, okay, do you want to buy this company's product? This company's product is low quality, cannot last for long. When you buy it, very expensive, maybe, or maybe low quality, or when you use it, maybe 1 in 2 days already broken, or you buy this product but cannot function. So if customer not come to you, but the customer come to their friends, their families member, then you see, you might lose a potential customer. So that's why quality is very important in the production line, not only production, but in service. If you think one day if I just conduct a class, I just read the text for you, then you might say, sir, you read like this, I also can teach one. So you have this mindset, then you might tell to your junior, do not take circuit class because he read the text. I also can teach you. You say you can teach the junior. So you you ask junior come to your class. So you also can provide the same service, right? So this is regarding to the quality. So once I cannot provide you a good quality, then I might lose my customer. I might lose my potential customer. So this is quite important, the quality issue, not only for service, but also for the product. Yeah, so far, any question from you? Okay, if no question, I think I will stop right here. So make sure you can block R control chart, X bar control chart. So tomorrow we will continue. Okay, tomorrow we will continue for another two. Another two page. X bar control chart, X control chart, and individual control chart. So if time allow, we will cover this two page of the control chart. So maybe to save the time, you can get the data ready. So no need to type the data during our discussion. I mean, we no need to spend the time to just for you to key in the data. You can get your data ready. So the data actually is come from the deck, come from the ebook. Can you do it?
Which ones?
Good. Yeah, I see your thumb out. Okay, so we meet again tomorrow. Tomorrow also online. I know many of you not in the asrama, not in the campus. You already back to your home. And next week we also do online because next week Sunday is Deepawali, and then university already give the notice. Next week should do the online class. Okay, so see you tomorrow at 10 online. Okay, bye bye.
Thank you, Doctor.
Thank you,
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.